Okay, we're back, and we're going to talk about a really cool property in math called an invariant. Have you ever heard that word before?
No.
Invariant. They're really important in advanced math, and they help solve problems. And you know where else? You see it a lot in physics. Energy is something that's an invariant in physics, and momentum is an invariant, and things like that, and they help you solve problems. Okay, so we're going to look for something that stays the same every time we move on this board. Okay, so remember, our move, it goes, you start out with 1, and then it cuts into 2 things.
Okay.
Okay, and it moves up either across or up. All right? So, why don't we pick a starting number? What number would you like to start with?
Start on 1.
Start with 1. Okay, so we're going to say this square here is worth 1.
Okay.
Okay? And when you split into 2 pieces, what should we call that?
A half.
A half. Okay? So there's our starting position. And what do these numbers add up to? 1 plus a half adds up to?
2.
Adds up to 2, okay? Now, every time one of our people in the prison moves out of the prison, we want to keep their value the same. So if I start at a half and get cut in half?
You get a fourth.
A fourth. So they can move, anytime they're on this diagonal here, they're going to be worth a fourth. Can you give me that other 1/4?
Okay.
Right? And what about the people who are on the 1/4? And when they split into what do they?
They become eighths.
They become eighths. And what did the eighths become?
16ths.
Okay, can you help your brother put the 16ths on, please? Start here. Okay. And then the 16ths become?
30 seconds.
The
Wow.
16ths become the 32nds.
Maybe we
Okay.
shouldn't go up to 64.
Okay, yeah, we'll just put these on. Hopefully those show up on camera, and if they don't, then hopefully, I don't know what to hope for. Okay, so what are the people in the prison worth total here on their squares?
They're worth 2.
2. So what we're going to try to figure out is if you can make 2 outside of the prison. Okay? Now, outside of the prison is worth what? Well, let's look at all of the squares. Okay? So outside of the prison, the first diagonal is how many fourths?
It's 3/4.
3/4. What's the next diagonal with the ace?
Fourths.
4/8.
That's a half.
And what's the next diagonal?
5/16.
5/16.
And 6/32.
6/32, and on and on and on, all the way out to infinity, right?
Yeah, well, this
So if we can figure out what this sum is, we'll know if you could even conceivably get these guys out of the prison, because initially they add up to 2, right?
Yes. Yeah.
So if this adds up to more than 2, maybe you can get them outside the prison. Okay,
Well,
have we ever seen a sum like this before?
I think so.
When?
I think it was in the I think it was in 114A.
Oh, the thing we started out with. Should we go away from our chessboard and back to the study room?
Yeah.
Cool.
Okay,
Yeah.
let's go. Hold on a second. Okay, so we're back in the study now. And we have this sum we're trying to add up. 3/4 plus 4/8 plus 5/16 plus 6/32. Do you see that on the board anywhere? 3/4, 4/8, 5/16.
It's right here. It adds up to 1. Wait, no, wait.
3/4 plus 4/8. Okay, can you show me? Do you see that anywhere on the board?
It's up there.
Oh.
Okay, it's part of the series
But
that adds up
it adds
to.
up to 4.
Okay,
Well,
so
except for the
1
same
plus 2/2 plus 3/4 plus 4/8 plus 5/16 plus 6/32. That all adds up to 4. So I wonder what 3/4 plus 4/8 plus 5/16. Can you put on your face?
I think it adds up to exactly 2.
Why do you think that?
Because we're missing these 2 first terms, and each of those terms is worth 1.
Okay, interesting. So this is 1 plus 1, which is 2.
And
And 2 plus the series we're trying to add up, 3/4 plus 4/8 plus 5/16.
that's gonna equal 4.
That equals 4. So the series we're trying to add up adds up to
2.
2. And we got that. We figured that out just from the thing that our New York teacher friend, Mr. Honner, put together. Pretty cool. Okay, ready to go back to the board?
Yeah.
All right. Okay, so here we are. So we just found out that all of these
Things that are
squares add up, outside of the prison, add up to 2.
cool.
Right? Now let's see what happens when we start making moves in the prison. Okay?
Yeah.
this one moves from a half and goes to a fourth and a fourth.
Yeah.
What's the total sum of all the cubes on the board right now?
It's still 2.
It's still 2. Okay? Now, when this person goes from a fourth to an eighth and an eighth, what's the total sum of all the cubes on the board?
It's still
Still 2. When this person goes from a half to a fourth and a fourth,
It's still 2.
it's still 2.
Looks like it stays at 2.
So the sum always stays at 2. That's the invariant. Isn't that neat?
Cool.
Okay. Now we're trying to make a sum with no cubes in the prison that adds up to 2. But we just found out that the infinite sum, when I fill up every single
Space.
square outside of the prison,
Yeah.
all the way to infinity,
Yeah.
that adds up to 2. So can I ever get this out of the prison? Get this one out of the
I
prison?
don't think so.
No.
No, because are we ever going to actually get to 2 and after playing the game like 20 times? Are we going to fill up all infinitely many squares after 20?
No.
After 100?
No.
No.
After 10 to the 10th?
No.
After a Google?
No.
No, we never quite get to 2 in any finite number of steps. Isn't that interesting?
Yeah.
Cool.
So we can never ever get all 3 of these cubes out of the prison.
Cool.
Can you believe that?
Whoa.
Isn't that amazing?
Yeah.
And that is an amazing technique in math called looking at invariance. And that helps you solve all kinds of interesting problems in math. It's a very advanced technique. But I thought it would be fun to show you because here, when the invariant is just 2,
Yeah.
it's easy to understand.
Cool.
Pretty neat, right?
Yeah.
All right. Good job, guys. Good job.